In this video, I want to focus on the insurance problem. So insurance is a very common exam questions under the uncertainty umbrella. And in today's video, I want to give you the common setup so that it's clear how the common setup in most of this micro courses differs from everyday insurance. And then we'll specify what the consumer problem is. So what's the common setup? Well, so far we've been talking about lotteries. Insurance is also a lottery. So the common setup in micro courses would look something like this. We have a lottery and we have a good state of the word, good, where nothing happens. Okay. Here you retain your wealth. So W is your initial wealth. Of course, measured in money. Okay. And then in a bad state of the word, bad, which will happen with some probability P, and the good one will happen with 1 minus P. What happens is that you have a loss. So you have wealth minus a loss. Now, this would be, if you like, your lottery with no insurance. Now, let's stop here for a second just to understand what's going on here and how is it different from a real world situation. Well, first of all, we're assuming that there's only two states of the world, which is probably not the case. And what underpins that assumption is that we know precisely how much are we going to lose. So if our house burns down, we don't really know exactly what the damages are going to be. If we get burglared, we don't know exactly what the damages are going to be. So in the real world, insurance contracts are a lot more complex, but we can make the main points we want to make with very, very simple lotteries like this. Okay, so this is the case of no insurance. And the next question is, how does insurance get sold? Well, we're going to look at one way how insurance gets sold. So how do you purchase insurance? And the way that we're going to think of a lottery with insurance is that we buy rights of some payouts. We buy payouts in the case of loss. Okay. And these payouts are in monetary terms. Okay. So what we're going to have here is that in the case of a loss, the insurance company is going to pay us some X. So X is going to be the amount of coverage. And of course, X, we expect to be less or equal to L, which is if it's exactly equal to L, we're going to call that full insurance. So the loss could be, for example, a loss of 200 pounds, and the amount of coverage that you're getting in case of a loss might be 100 pounds. Okay. So X we're going to assume as the amount of coverage. And for that coverage, the insurance company will charge you Q, which is a premium per unit of coverage. And of course, if you think about this for a moment, a Q is a premium that you're going to pay for 1 unit of coverage. So this better be less than one, otherwise no one would be willing to purchase insurance, and greater than zero. And this premium, they take it from you up front, if you like. In other words, you're going to pay for this premium in both cases of the world because it's been taken already from you. How much are you going to pay? Q per every unit. So if you're purchasing X unit, you're going to pay Q times X. And of course, because you are prepaying for this, and that's one way that you can think about it in this setup here. You paid it immediately to the insurance company, which means that will decrease your your money in both states of the world, both in the good state and in the bad state. So it's important that you actually get this set up right. And then you understand that there is X is an amount of coverage, Q is a premium per unit. Of course, I could have done this differently. I could have said that, the insurance that I'm trading is a take it or leave it offer. I give you an amount of coverage for a fixed premium. So it might not have been a amount of coverage. But this setup allows us to have a nice consumer problem. So this is a lottery with insurance. And finally, what we want to do now is what is the consumer's problem? Well, the consumer's problem The consumer's problem is to find the optimal X or the optimal insurance. And here we're going to use our assumption of expected utility maximizer. So we're going to take this utility with insurance, which is for any arbitrary level of X. And if actually we're going to represent what is the expected utility from this particular lottery. How happy is the consumer? So the expected utility now is going to be as a function of this capital X is going to be P probability. I'm going to get this amount of money, which is going to be this amount of money, which is going to be the input of my utility function. So I'm going to be given some utility function, which is going to take in as input that amount of money. I don't know what the utility function is. It will be almost certainly a concave utility function because we'll be dealing with risk-averse individuals. So that's the probability of a bad outcome plus 1 minus p. Again, u, and I'm making this with a different color just to remind you that this is the function, and the thing inside is simply the the amount of money that you will get in that particular case of the world. So this is the consumer problem. That's what the consumer is trying to do. So the consumer is trying to find some argument. What argument? Some argument X that would maximize the expected payoff. So in optimization terms, this is now your objective function. So to recap, in this video, we looked at the a common setup for the insurance problem, and from that common setup, it allowed us to set up what the consumer problem in a insurance problem would be. And in the next video, we will solve this consumer problem.